This is a two-player game. Player A and player B take turns to do something to a diagram. You begin with a rectangle, and then each player must remove either a column or a row from the diagram, but they're free to choose whatever they want. And the game is you win if you are the last person to remove a file. Now we begin by looking at this small case. We suppose that A removes the central column. B then removes a file, and there are all sorts of things that B could do. B could remove that file, or this one here consisting of a single square, or this one, a single square, or that single square, or that single square. So B has lots of choices. So suppose player B decides to remove that horizontal file of length 1. The question is, how can A win? Well, here's one way that A can win. A could remove that file, because B then has to remove that or that, and then A gets to win. So now we consider a slightly larger situation. This time, player A is confronted with an initial rectangle, which is 20 by 25. And the idea is to see if A has a winning strategy. And inspired by what happened just now with the 2 by 3 case, let's see what happens if we remove the central file. There is a central file because 25 is odd. We've now got two problems. We've got a problem of a 20 by 12 and an identical problem over here of a 20 by 12. But it's B's go. A can still win. What they do, well, I'll give you two strategies. First strategy, just consider these as copies of one another. So supposing B removes a file, perhaps this one, then A can respond by taking the reflection of that file in this diagram. And then we carry on. Whatever B does, perhaps B removes the file. Then what A does, they respond by taking the reflection of that over here. And because A always copies and produces something which is symmetric about the central vertical axis, it must be that A has the last turn. So A wins. Now this is going to work for any even by odd rectangle. A is going to be able to win by removing a central file and then deploying the copying strategy. So now we want to think about the case where both dimensions of the rectangle are even. And A's strategy that we've used so far doesn't work because there's no central file to remove. But nonetheless, we can play with the strategy that A deployed on the 20 by 25 rectangle, do something slightly different, and this change strategy will work for even by even rectangles. So A begins by removing the central file. B does whatever they want to do. So for example, B might remove that file. Now, in the old strategy, A would then remove the corresponding file on the left-hand side, the reflection. This new method is going to be to rotate this removed file about the central point through 180 degrees. So A responds by removing that file down there, creating a configuration which is rotationally symmetric. If you took this diagram and rotated it through 180 degrees about this central point, it would look exactly the same. B has no choice but to break this rotational symmetry. Doesn't matter what B does. B might, for example, remove that file, in which case A would respond by removing a file which is there. So A always creates something which is rotationally symmetric, and B always breaks it. Now, to finish, you have to remove all the files, and that's rotationally symmetric. So this strategy also works for A in the case that you're dealing with an even by odd rectangle. But now, this is going to generalize. So now we have an even by even rectangle to look at. A is going first, but this time A is going to lose. The reason is that B can always copy A's moves by using a rotation about 180 degrees through the central point of the rectangle. So it doesn't matter what A does. For example, A might remove that rectangle, that file. If they do, what B does is to rotate this about this central point through 180 degrees and remove the corresponding rectangle over here. This time it's B who is in a position to create something which is rotationally symmetric. Now, it doesn't matter what A does. For example, A might do that. B responds like that. And they carry on. Every time, B can create rotational symmetry and A has to break it. This time, it means that B is going to win. And that's the answer.